All right, so we were talking about a circular coordinate system, which we call what? What is that called? The polar coordinate system, right? So one of the things we did yesterday was we found rectangular coordinates for maybe 2, 168 degrees. So one of the exercises we did yesterday was, let's take an ordered pair. This is what? What's the 2? Not x. This is not x and y. What is this? The 2 is the radius, and 168 is the angle in standard position, right? Now, we want to change that into x and y. And I know it was right at the end, but I gave you a huge hint. I mean, a huge, not really a hint, but a tool. What do we know about x and y? Always, always, always. What do we know about them? Jamie?
It's r.
Exactly. X is always going to be r cosine, and y is always going to be r sine. And that is not new, because back in November or October, whenever it was, I had you memorize that cosine theta equals x over r. You memorized that, supposedly. Well, if you move the r over here, what does it say? X equals r cosine. It's exactly what you already know. There's nothing new there. So, if I want my rectangular coordinates, x will equal 2 cosine 168, and y will equal 2 sine 168, and I can type that in on my calculator and come up with the answer, and it's that easy. Okay? Absolutely nothing to be concerned about with that problem. So negative 1.96. Now, I'm not saying there aren't other ways to do the problem, because there certainly are, but oh my gosh, this is so easy. All right? And then not only did we take polars and change them into rectangulars, but yesterday we also found polar coordinates for rectangular points, like -3, -1. Remember that? Okay, now what did we do? Remember? How did we find, what are we looking for? What are we trying to figure out?
Radius.
We're trying to find r and theta, right. So do you remember how we did that? Yeah. We drew a
Triangle.
picture, yeah. We just plotted that point, -3, -1. And then, you don't have to draw it in, but can you envision the circle there? So what's this?
Radius.
That's the radius, or the magnitude of that vector. And so what would the radius be?
The hypotenuse.
Yeah, which would be about how long? Root 10? So r is root 10. Now be careful on this one. This is theta. Now what's going to be our strategy to find theta?
Find the smaller angle.
We'll find the angle inside the triangle here, and then add it to 180. Now how will we find the angle inside the triangle?
Tangent.
We'll say the tangent of that angle equals 1/3. And I got 18.43, which means the actual theta is 198.43. Now, that problem is on tomorrow's Monday's quest. Only it won't say find r and theta. What will we be looking for? This is the magnitude of the vector. And And what do we call this in terms of the vector? In terms of polar coordinates, it's theta, but we call this the vector's direction angle. That's the direction it's pointed in standard position, 180 degrees. Okay? Now, I want to add one piece to this. Do you remember yesterday talking a little bit about the fact that actually you could name this angle other ways? Remember we talked about that? This is the best way. This is the way when we get to what we call polar form or trigonometric form. That's the angle you're going to want to use, and that's the angle you use in vector land, the direction angle. But you could also name that angle this way. Wouldn't that name the same position? So we talked about there were other angles we could use. Well, kids, it gets even a little bit wilder than that, believe it or not. It is possible in polar coordinates to have a negative R value. Now, I know what you're thinking. You're thinking, whoa, 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 Miss Ford, that does not even make sense, because how can the radius be a negative number? And I understand your question completely. Unfortunately, when we sketch, sometimes R comes out negative, and we have to be able to deal with that. So what this means, anytime you see a negative R value, it means the vector is pointed in the opposite direction. So here's what this point would look like. These 2 points are the same. This negative R value tells me that the actual vector is opposite 18 degrees. Now when I say opposite 18 degrees, okay, if this is 18 degrees, what would be directly opposite it? This, right? And how many degrees difference is there then between this one and this one? 180. So whenever you have a negative R value, it simply means that the actual vector is not on the angle it says. It's actually on the opposite angle. So you would not, well, you can't plot that, it's negative. This point would end up getting plotted with a positive 2, and what would be the angle? 190. Let's try another one. If you were working along and you found negative 3, 150, and you had to plot that, you would know, because of that negative, that it's on the circle with a radius of 3, but it's actually opposite 150. So wherever 150 is, go directly opposite, and where would that be? 330. Kids, you're in a circular system. Directly opposite is how many degrees difference? 180, right? So if you ever have a negative R value, just remember it's plotted in the opposite angle, 180 degrees different. John, yeah, quickly.
Does it work the opposite way where like you do like -40?
Yeah, yep, you sure can. Now, again, normally we're trying to keep these angles between 0 and 360, but yes, that would be exactly right. When I say 180 degrees different, we can add 180 or we can subtract 180. Yep, for sure. Okay, so one more. If you had to plot 5, 300, excuse me, negative 5, 300, where would you actually put that point? It would be on a circle with a radius of 5, but it wouldn't be at 300. Where would it be? 120. It would be 180 degrees different, opposite. Okay? So when do we worry about that? Only when the radius is negative. When the radius is negative, we plot the opposite point. Okay? All right. A couple more things, and then we'll just do your review questions that you might have. called a polar equation. Does that make sense to you? It's an equation. And what are his variables? R and theta? So suppose I said to you, change to a rectangular equation. This is a polar equation, and in a minute we're going to get our calculator out and graph it. But for now, the directions say change to a rectangular equation. Now, do you have any idea what that means? What do I want you to do? What did you say, Jamie? Exactly. Come up with a new equation, but the variables have to be x's and y's, because rectangular means x's and y's. All right, cosine theta. I just had it on the board and I erased it. What do we know about cosine theta, you guys? It's x over r. Let's just go ahead and substitute that in. Now, had that been a sine theta, would you have a substitution for sine theta? Y over r. What if it would have been a tan theta? What's your substitution for tan theta? Y over x. Don't we have a substitution for every one of our functions because we memorized them? So whatever you've got in the problem, change it. Put in your definition. In this case, x over r. Now let's get rid of the fractions. So I'll multiply by r. Is that okay with everybody? I'm going to come over here for a minute and I'm going to draw this picture. This is x and this is y. Would you agree with me? This is r. And this is theta. So this picture shows the horizontal and the vertical. It shows the radius and it shows the direction angle. This is a right triangle, right? What can you tell me about r squared? I got an r squared in my problem. What can you tell me about r squared? Okay, well, certainly it's the radius of the circle. But in terms of that triangle, what can you tell me about r squared? Doesn't x squared plus y squared equal r squared? So see this guy right here? Guess what I'm going to do with him? Change it to x squared plus y squared. Now I want you to look at the equation that I have here. What are the variables in that equation? Just put it in plate, thank you. What are the variables in that equation? X and y. What was my goal? I'm done. We did it. This is our equation. This is the equation that was described by these coordinates. So let's talk about how we did that. What magic did we do? What was the first thing we did? We defined our function. So if it's sine, we put in y over r. If it's tangent, we put in y over x. We had cosine, we put in x over r. Then we just did a little arithmetic. We just cleared up the fraction out. And then what was this magic right here? What's this? What's going on there? That's the Pythagorean Theorem. Will it always be true that x squared plus y squared equals r squared? Always. So if you ever have an r squared, you can substitute this in. If you ever have this, you can substitute that in. All right, let's try one more. Okay. But bigger equation this time. Let's see how you do. Okay, the directions say rewrite as a rectangular equation. Okay, so think about what we did here and let's repeat the steps. So what did we do first? Okay, so we got two of them this time. So what's sine? Y over r. What's cosine? X over r. what do we do over here?
Multiply the amount.
Am I keeping you awake?
What?
Am I keeping you awake?
No, I just barely.
So we multiply everything by r. So we end up with r squared equals 2y minus 4x.
And you replace the r squared with x.
Now, I'm not saying that's the most gorgeous equation in the world, but what were our directions again? Make it rectangular. And what does that mean? If we're going to make it rectangular, that means our variables have to be x and y. Have we accomplished that mission? So if you want to do other things, I don't care, but you don't need to. Stop right here because you've accomplished the task at hand, which was get rid of the r's and thetas, change them into x's and y's. Okay? Now, we're going to do one more problem, then we're going to graph something on our calculator, and then we'll be done. The last problem I actually want to do is the backwards of this. Suppose we had to change 3x minus 2y equals 8 into a polar equation. Now, anybody who ever misses this problem, I don't know what I'm going to do. I'm going to do something to you because this is the easiest thing you are ever going to do. A little bit ago, we said x equals what? What does x equal? R cosine theta. We're going to remember that. So guess what I'm going to do with that x right there? I'm going to take it out and replace it with r cosine theta. Now, what do you think I'm going to do with that y? Replace it with r sine theta. Now, all I did was take out the x and the y and put in my substitutions. Now let's look at the equation that's left. Again, it isn't the most beautiful equation in the world, but what are its variables? R and theta. What was our job? We're done. That's it. Done, done, done. That's all you have to do. Changing into a polar equation is a snap. If there's an x in the equation, take it out and replace it with our cosine theta. If there's a y in the equation, take it out and replace it with r sine theta. Kids always get confused. What if there'd been a squared on that x? Who cares? That just means this is squared, right? It isn't a big deal. You can handle any x and any y. Just substitute in our cosine theta and our sine theta. Okay, got it? All right, get your calculators out. I gave mine away. And we're going to graph only one equation. We don't have time. I'm going to get some review done. But we're going to graph this equation right here, okay? So, first thing we do is go to mode. And remember on your test now tomorrow or Monday, you'll have to go to what mode? Parametric. But now we're going to go to polar. So go to polar mode. So that we're all on the same page, so let's go ahead and switch into radians. Actually, let's leave it in degrees. That way I won't have to worry about you guys messing that up on Monday. So we're in polar mode and we're in degrees. Everybody good? Now let's go to our window. We're going to be graphing this equation right here, and we are in degrees. So theta min needs to be 0, and theta max needs to be 360. Does everybody understand that? If I were in radians, I would be using 0 and 2 pi, but I'm in degrees, okay? Now theta step, let's just change that to 5, the number 5. And again, we're going to spend more time talking about that when we graph more of these. But right now we're just doing 1, make it 5. let's change x min and max and y min and max to 8 and negative 8. And then we need to go to y equals and type in our equation.
Is theta just x?
Uh-huh. When you press your X button, it's going to come up as a theta. If your calculator puts parentheses in when you like press cosine and sine, make sure you close the parentheses. Now, we talked a little bit about this the other day. Your calculator screen is rectangular, so everything you graph is warped. So if you press zoom and go down to z square, it will square your screen and you'll get a more accurate picture. What shape did you get? A circle. That makes sense. Isn't an equation that looks like x squared plus y squared, isn't that a circle? Now this junk says it's not centered at the origin. It's shifted over a little bit. That moved the center. But this is indeed a circle.
I got an error.
Okay, I don't know. I'll look at it. It's not. Right now, we got more important things to do than that. You didn't press the buttons I told you to press. All right, now let's do some review. Hang on to all that. Not reteaching all that. That's your lesson. Hang on to that. We're going to pick up with that on Monday. Oh, speaking of Monday, Quest and then Pi Day celebration. Remember, bring in something round and edible for bonus points and celebrate. Okay. Who had a question about one of the problems on pre-quest number 2? Robert.
Number 2.
Number 2. Okay, this was your e-learning assignment. I cannot tell you how frustrated I am with your lack of, not you, Robert, specifically, I'm talking in general, everybody, lack of effort on that. Did anybody watch my nice little e-learning video in which I did 2 problems exactly like this? Can anybody help me out? Someone needs to talk because I'm not starting fresh. I did this already. I'm not starting fresh. Somebody get me started. What do I need to do? Victoria.
Graph and then make the coordinates say 0, 0, 0, 0.
Well, actually, I don't absolutely have to have a picture, but I can, so I'll go ahead and do that. So, and actually, I think you're right. I think it would help. So I'm going to draw a picture of the plane. He's on a bearing of 215 degrees. Now, this is different. When we're talking about direction, where do I start measuring that 215? I don't start here. This is standard position, and everything else starts here, but not directions. Where do directions start? At the top. This is 0. And this is 90, and this is 180, and this is 270. So 215 would look like this. Now, I need the components of that, and this is 310, the magnitude's 310, they tell me in the problem. I need the components of that vector. This is the airplane. I need his components. What do I mean by that?
All of the parts. we need the
I need
coordinates.
X and Y. So I can find X and Y, can I? So I know that, okay, let's see, this is 215. How big would this angle be if that's 215? This one would be 55. So I can say the cosine of 55 equals X over 310. So 310 cosine 55 will be X, and what will be Y? 310 sine 55. So that will give me the components of my airplane. So 310 cosine 55. Now, we have to be careful about something, though. What do I have to pay attention to? Where is that vector drawn? Which quadrant? Tell me about X and Y in quadrant 3. They're both negative, so I gotta put those negatives in there. What that tells me is, the way this airplane is flying, he's going left and down. Alright, now guess what I'm going to do. Same thing for the wind. So he's 160 degrees. Again, we're measuring from due north because that's a direction. His magnitude is 62. And I need to know X and Y. So how big is this angle right here?
70.
This is 160, so this has got to be 70. So the cosine of 70 equals X over 62. So X equals 62 cosine 70 and Y equals 62 sine 70, right? So my wind anything negative in that one? Y has to be negative. This wind is blowing right and down. It's in quadrant 4. So this is the X of the wind of the plane, and this is the X of the wind. They're working together. I mean, they're both happening. How do you think I'm going to find the actual X and Y of the plane? This is the course the pilot set him off on. But then the wind blew him. So I want to know what's the result.
Dot product?
No, I know dot product. I just add them. I want the resultant. I want to add them. What happens when I put these two forces together? So when I put the two forces together, the actual course of the plane, or components, I should say, the actual components of the plane are negative 156.6 and negative 312.2. So if I drew a picture of the actual components of the plane, it would look like this, right? They're both negative. Now, the question, though, doesn't say find the actual components. The question says find the speed and the direction. Now, when I originally drew the plane, 310 was his speed, right? And where did that show up in the problem? Was that x?
No, it's magnitude.
That was the magnitude. So if I want to know the actual speed of the plane, what am I going to do? Find the magnitude. I got 349.27, but I don't know. Typing with gloves is kind of not good. I think that's right. So the plane is actually going 349 miles an hour. So what does that mean? The wind's making him go faster. The wind's pushing him a little bit. Grace?
If we like rounded differently and we got like 352, would you pounded it wrong or right?
I actually just squared one of these numbers that was already in my calculator. I don't know, I'll have to look at it. That seems to be off a lot, but I don't know. I'll look at it and see. I don't know. I need you to know how to do the problem. You need to find the magnitude of that vector. Now, I need the direction of the plane. In the beginning, he was this course. Now, he is this course. That's his actual direction. How am I going to find that angle?
Find the angle inside the triangle.
I'll find the one inside here. And do what with that? Let me get that real quick. So I got 63.36. You may have rounded differently, be in that ballpark, 63.36.
Subtracted to 270.
Subtract it from 270. So the actual course is going to be 206.64. So the wind not only speeded him up a little bit, but also pushed him off course, right? How many of you have been on a flight where you've arrived before they told you you're going to arrive at a certain time and you actually got there earlier? This is why. This is part of the reason, could have been part of the reason. And luckily there are computers that do all this. It used to be the navigator did it. The actual guy in the cockpit did it. But now the computers do all this stuff. So when that plane takes off, if this is where he wants, if this is the course he needs to be on, he'll make an adjustment before he takes off to take that into account so that when the wind blows him, he'll actually be on that course then. So you end up where you want to go and not, 10 degrees off, which is a big difference in the world. All right, so we got that figured out. So what were those steps again?
You gotta find the coordinates, the components for
We
both.
got to find the components of each
Then you have to find the components.
vector, add them together, and then if the question had said, find the components of the resultant, that's it. But it didn't. It said find the magnitude and the direction. Now you have got to keep this straight, kids. Normally, the direction is going to be measured from here. So if it says here's a vector, what's its direction angle? It's measured from here. The only time we measure from up here is if we have a direction problem. They've given me a bearing. They've said you're on a course of 18 degrees. Then you measure from up here. Otherwise, you always measure from here. Okay? All right, I'm going to go ahead and hand this stuff out so that everybody has it. And then we'll take some more questions if you have them.
Big Sunday.
That I kind of wish that. I really hope he does.
This is stuff for next week.
Oh, God.
And I have one for Hannah.
I will go regardless. Last year, we the house set up like 5 minutes late. It's like we were dressed up like all of us.
All right. So did everybody get a packet? This is for next week. We don't need it right now, but I want people to have it. Everybody got it? All right. What other questions did we have then about our homework? Okay, Alex, you can. No Trevor Ford. Marcus came in. No Rose, no Katie James, no Sarah, no Teresa, and no Anna. Yep. Yep. I don't know. Let's see what number 4 is. Find a unit vector in the same direction as 1, 3. How do we find a unit vector, folks? You guys, we did this yesterday. How do we find a unit vector? We got to find the magnitude of the original vector. So, okay, well, what's the magnitude of the original vector? Root 10. And then what do we do with the root 10? We divide each coordinate by that. That makes it a unit vector. That's how you make it a unit vector. You simply divide the coordinates of the vector by the magnitude. That's all there is to it. All right, who else? Your homework then for tonight is to do that worksheet number 3, which I gave you yesterday. And I have not checked those answers, so if you find one that's wrong, it could very well be wrong. Feel free to email me if you have a question about that, and because I don't want you losing sleep over it. I don't know. You'll have to go get one, I guess. I don't know. I can't get track of that. Go get one all the time.
Okay, can I do it during 4th period?
All right, you got 7 minutes. You can use this time to get busy, and I need to look at your calculator.